Okay, today we're going to be working on problem-solving strategies. Let's go ahead and look and see what our lesson objective is today. Okay, we're going to be working on TEK 3.4K, and it's solve one-step and two-step problems involving multiplication with 100 using strategies based on objects, pictorial models, including arrays, area models, and equal groups. And what we need to be able to do by the end of the lesson is I can use the correct model in solving multiplication word problems. I can make a plan on how to understand what the word problem is asking me to do, and I can multiply a two-digit factor by a one-digit factor. So let's go over here. I'm going to show you an example. Well, let's go ahead and look at some of the vocabulary here. And the vocabulary is pretty much the same as we talked about in multiplication before. Product is the answer to a multiplication problem, and factors are the two numbers that we put together, or however many numbers we put together that we multiply together. Those two, the numbers we're multiplying together. And today, like we said in the I-can statements, products up to a two-digit factor by a one-digit factor. So we're going to be multiplying, doing a multiplication problem, a two-digit by one-digit multiplication problem. Okay, this multiplication we're going to look at today is 5 times 15, or 5 groups of 15. And I'm going to show you a couple of different ways anyway to work this problem out. So the first way I'm going to do is I'm going to show you an area model. So we said 5 times 15 is 5 groups of 15. So I'll go ahead and just draw an area model that represents 5 groups of 15. So I'm going to go ahead and make 5 rows. And I'm going to do 15 squares long. Still working on my drawing techniques here. So I could go through, there's a few different ways to do it. I could skip count by 5s. I can do the inverse of it. I could say, 15 groups of 5. Skip count by 5 15 times. That's one way of doing it. I could go through here and count all these squares. That would show me a way of doing it. Or I can break it down into a couple different problems here. So I can break it down into 10 plus 5. So that we'll make this 1, 2, 3, 4, 5. So this is going to be basically a square that's 5 by 5 by 5, or 5 by 5. And this rectangle over here is going to be 5 by 10. So if I'm trying to figure out the area of something, I'm multiplying those numbers together, and 5 times 10, I know 5 times 10 is 50. And then 5 times 5 is 5, 10, 15, 20, 25. 5 times 5 is 25. Or one of our strategies for 5s was to take half of what 5 times 10 is. And 25 plus 25, we learned that with our money, that 2 25s make 50, so half of it would be 25. So 5 times 5 is 25. And then all I'd have to do is do an addition problem and add those two together. That'd be 50 plus 25. So 5 plus 0 is 5. 2 plus 5 is 7. So 5 times 15 would be 75. I'll show you another way of doing it. I'll show you we call it the standard algorithm of doing multiplication problems. And we'll do that over here. I'll do it a little bit bigger. So that'd be, I put the big number on top, 15 times 5. And I stack the numbers up like that. Not plus, but a multiplication sign. And a few years back, when I started teaching 3rd grade, my students, I asked them, we call the standard algorithm, but they came up with a Hart method, and I'll show you why. So the first thing we're going to do is we're going to multiply the ones place by ones place, basically. So 5 times 5, we said earlier, okay, is 25. And I can't put 25 in the ones place, so I got to regroup and put the 2 over here. I'm going to circle that. Just remember I need to use it again. And then I'm going to go ahead and multiply the ones place by tens place. And 5 times 1 is 5 plus 2 would be 7. So 15 times 5 is 75. And the reason they called it the heart method is that when you circle the what you're multiplying, it sort of looks a little bit like a heart right there. So they called it the heart method. They made that up. But basically, the strategy is you multiply the bottom number by the ones place and the bottom number by the tens place, and then if you need to regroup when you're multiplying the ones place, you regroup, and that's called the standard algorithm. Okay, we're going to look at this word problem now. And it says, Austin was on summer vacation for 7 weeks. He spent 3 weeks at band camp, and the rest of the time he spent at home. How many days did he spend at home? So I'm going to use my cube strategy, kind of help me organize, maybe see if I can make an understanding of what the problem really wants me to do. So first thing I'm going to do is I'm going to go ahead and circle the important information. That's usually numbers and labels. So I've got 7 weeks. That's the amount of summertime, or the summer vacation. 3 weeks, and that's at the band camp. And I'm going to go ahead and circle this too, days right here. And that's what we're trying to find out, how many days he spent at home. So next thing I'll do is I'm going to underline the question. So the question is, how many days did he spend at home? That's by the end of this problem, when I'm done, I need to be able to answer how many days he spent at home. So I'm going to go ahead and box in some operational clues, or maybe some clues that maybe tell me stuff I need to do. And right here, I'm going to go ahead and put a T right here, because the total amount of time that we're talking about is 7 weeks. And I'm going to box in this right here, the rest of time. That's kind of giving me some clues there. At some point in time, I think I'm going to have to do some subtracting in this problem. So a lot of times the rest or whatever's left over, that's kind of telling me there's going to be some subtraction happening in this problem. So I'm going to evaluate now. One thing I evaluate, okay, I got 7 weeks and 3 weeks right here. Okay, the labels are the same, but when I look back over here, my answer is going to be in days. My answer is in days. So I'm going to have to do some sort of a conversion there. I'm going to have to convert the weeks into days to solve this problem. So the next step is solve. So one other thing, I guess, with evaluating, I'm going to write a little note over here, because since my question's talking about weeks and I need to figure out about days, I need to make some sort of conversion. And basically the conversion I'm going to do is 1 week equals 7 days, because there's 7 days in a week. Just put a little abbreviation. So I need to remember that at some point in time I need to do some sort of conversion and convert from weeks to days. So I think the first thing is I'm going to go ahead and figure out how many weeks was he not at band camp. So if I was to do that, I would go ahead and take the amount of, so that's how many weeks summer vacation was, and 3 of it was at band camp. So to figure out the rest of it, I would do a subtraction problem. So that means he spent 4 weeks at home. Weeks. Okay. And if you look over here at my answer choices, I have 4 days as one of my answer choices right here. But and that's kind of put there to kind of trick you up, because the 2 numbers we have in the problem are 7 and 3. And if you subtract the number 7 and 3, you get 4. And that is one of the steps that we have to do. We do have to subtract, but that's not it. Okay. We still have to change the 4 weeks into days. So in order to convert weeks into days, since 1 week equals 7 days, the math problem I'm going to use to solve that is going to be 4 times 3. Or I'm sorry, 4 times 7, because there's 7 days in a week, and 4 of the weeks he spent at home. So we're going to have to do that math problem. So one thing you can kind of do is we can make an area model and kind of maybe make it sort of look maybe sort of like a a calendar maybe. So let me do this, change it to. So I'm going to go ahead and do my days of the week. So I've got Sunday, make that a little bit smaller. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. That's my 7 days of the week. And each one of those, I'm going to put a dot to represent. So the first week has 7 days. So 1, 2, 3, 4, 5, 6, 7. And then the second week, 1, 2, 3, 4, 5, 6, 7. The third week, 1, 2, 3, 4, 5, 6, 7. And then the fourth week, 1, 2, 3, 4, 5, 6, 7. So that's an array that I can use to solve this problem. And one of the tricks that we did for trying to memorize our 4 facts is instead of skip counting by 4 7 times, I can just double 7. So double 7 is 14. And we double that again, 14 again. And 14 and 14 is 28. So 4 times 7 equals 28. And you look over here, 28 days, the answer choice B. I'm going to put a question mark there. Okay, we already figured out that D is not right because it's talking about 4 days, and they kind of put that there to kind of mess us up a little bit. It's red here. So they put that there to kind of mess us up, and it's not 4 days, it's 4 weeks that he has of summer vacation. Let's look at something else here. If I added 7 plus 3, it would have gave me 10 days, or it would have gave me 10. 7 plus 3 is 10. Can eliminate that. And also, if I went ahead and, okay, well, it looks like I could go ahead and multiply 7 times 3. I know 7 times 3 is 21. So each one of those answer choices was put there to kind of mess with us a little bit. So the correct answer would be 28 days. So we figured that out here because 7 times 4 is 28. Okay, we're going to go ahead and work on the we do part of our lesson. And I'll go and read the question to you. It says, Olivia baked 4 dozen cupcakes. How many cupcakes did she bake? So I'm going to use the KFC strategy. So we're going to talk about what we know, what we're trying to find out, any special conditions we have in this problem. So first off, we'll write what we know. And we know there are 4 dozen cupcakes. We know that for sure. So we got 4 dozen. Abbreviate cupcakes. 4 dozen cupcakes. The next thing, what am I trying to find out? I'm trying to find out how many cupcakes did she bake. So basically I'm just going to take and change that question and make it into a statement. I'll say that she baked blank, I can abbreviate cupcakes. And my special conditions. I guess probably one of the big ones is we need to figure out what a dozen is. And 1 dozen equals 12. So 1 dozen equals 12. So I'm going to do this a couple different ways. Okay, the first way, I'm going to make groups. So I'm going to do some groups right over here. So I'm going to do 4 groups because there's 4 dozen. And if I'm going to use base 10 blocks or pictorial model to model the cupcake. So that's 1 long and 2 units is 12. That's 10, 11, 12, 10, 11, 12, 10, 11, 12. And the problem I'm working out is I got 4 groups of 12. And that's not one of our multiplication facts, but we're still going to figure it out. So I can also go ahead and do like a little area model here. So I got 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so I can break that area model into, so that's 4 by 10 plus 2. So I can break down my area right here. That's a 4 by 2 model. And this is a 4 by 10 model. I know 4 groups of 10 is 40, and 4 groups of 2 is 8. So I could add 40 plus 8, and that gets me 48. Let's double check over here. I got my longs here. I can count those by 10, so that's 10, 20, 30, 40, 41, 42, 43, 44, 45, 46, 47, 48. So 12, 4 times 12 is 48. Okay, our next problem we're going to look at is there are 2 different vegetables in a garden. Okay, first bullet says there are 5 rows that have 16 carrot plants in each row, and there are 72 spinach plants. How many vegetable plants are in the garden? So I'm going to go and look at my important information. So I have, first off, I have 2 different types of plants, 2 different types of vegetables in my garden. First one we're talking about, there's 5 rows of it, and there's 16 carrot plants in each row. And then I also have 72 spinach plants. Next thing I'm going to go is underline my question, make sure I answer that. How many vegetable plants are in the garden? So that looks like a total type question. I got total right there. So box in some of my operational clues. I'll go ahead, box in each row. That sounds like equal groups to me. And I'm going to do a little bit of evaluating right here. I'm going to look at it. I have 5 rows and 16 plants. And we already said each row. So it sounds like equal groups. I'm not going to add 5 and 16 together. That doesn't make any sense. That's not going to really get me anything. I cannot add rows and plants or subtract that. So it sounds like we're going to be talking about equal groups here. So I like rows of stuff, so I'll go ahead and draw an array to represent my carrot plants. My carrots are orange, so I'll go ahead and there's 5 rows. So I got 1, 2, 3, 4, 5 rows, and there's 16 in each. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Then I'll go ahead and fill in all my other blocks below that. A lot of carrot plants there. And I got 16 in each row. I'm on my 4th row now. And I'm making an array. My arrays are equal rows, equal length rows. And I'm using my grid paper to kind of help me keep organized here. Okay, so I went ahead and drew it, and I'm not really good at multiplying. I can see there's a lot of counting there. I could spend a lot of time counting that. Okay, or I can go ahead and break it down into a problem, maybe make it a little bit easier. I know my 16 has at least one group of 10 in there. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'll take this area right here. That's 10. And I'm not super good at my 6s yet either, but I'm pretty good at my 5s. So I go 1, 2, 3, 4, 5. So that's 5. And that leaves me 1. So 6, basically I decompose 16 into 10 plus 5 plus 1. And I know I have 5 rows. So my first little part of my garden is 5 groups of 10, which is 50. My next little area is 5 groups of 5, and that's 5, 10, 15, 20, 25. So there's 25 carrot plants here. And this is one group of 5, which is, or 5 groups of 1, which is 5. So if I want to figure out what 16 times 25 is, I can just add all those together. So that's 50 plus 25, 25 plus 5. That's 50 again. So I add that up. 5 plus 5 is 10. I carry my 1. And then 5 plus 2 plus 1 is 8. So that means there's 80 carrot plants. 80 carrot plants. That still doesn't answer my question yet, because I need to know all the plants in the garden. So if I want to figure out all the plants, I would go ahead and add my spinach plants to my carrot plants. So I have 72 spinach plants, put an S there, and 80 carrot plants. Sounds like an addition problem. 2 plus 0 is 2. And 8 plus 7, I count up from 8. Count up 7 more, so that's 8, 9, 10, 11, 12, 13, 14, 15. So 8 plus 7 is 15. So it looks like 152 plants in the garden altogether. So I'm going to go ahead and choose answer choice A for that. Okay, it's time to complete your independent practice now. Please complete your Schoology assignment. You'll find it right below this video, and it's going to be a blue puzzle piece. It's a graded assignment, so take your time and do your very best. And just like always, if you're having any type of issue at all, go ahead and email your teacher or send them a message in Schoology. Let them know what kind of issues you're having, or if you don't understand any concepts or anything like that, and they'll be more than happy to help you out. Good luck and do your best.